All right, now we're starting on part two of our streaming example. In this example, if we look at the previous video, was that we had a camera trying to give a warning if it saw a sequence of red, green, and red. In that first part of the video, we came up with this state machine. And now we're going to continue working through our process of taking the state machine and moving it from the state graph, which this one represents. This is the state graph. And what we're going to do is change it over into a state table. All right, so let's figure out how we're going to go about doing this process. To do that, remember, we're going to create a little table out here. It's going to be in three different pieces. The pieces are output, which is our Z. We have our next state, which is where the arrow goes to. And that would depend on a 0 or a 1 on X. And then we have where we currently are, our current state. All right, so we have four states, an A, a B, a C, and a D. Let's figure out our output. How do we figure out our output? We look at the state. Here we say Z is a 0. So we know for A, Z is 0. We look at B. B is also a 0. C is also a 0. And then we look at D. Oops. And on D, we see we have a 1. All right, so that's how we get our outputs. Now let's figure out our next states. For our next states, we're starting with A, and we're looking for X is equal to 0. We've got to see where that arrow goes to. And we see that arrow goes back into A. So when X is equal to 0, we go to A. Okay, what about 1? We're at A, we follow that arrow of X is equal to 1, and we see we go into B. Right, now let's find B. Here's B, arrow when X is equal to 0. We see that it goes to C. When X is equal to 1, we see it goes back into B. Then we move on to C. C, when X is equal to 0, we see we go back over to A. When it's equal to 1, we see we're moving over to D. Let me just fix up this state machine here. All right, now we're at D. D, when X is equal to 0, we go to C. And then we look when it goes to 1, we go to B. So it goes to C and B. All right, so that's the state table. And that's our first starting off spot. Now, this table here is going to help us produce our circuit. Now, what we got to do from this table is we got to examine the number of states. And from this number of states, that's going to tell us the number of D flip-flops we're going to need. Okay, so we had, in this example, an A, a B, a C, and a D. So this was 4 states. To get to the number of D flip-flops, well, 4 is 2 to the what? It's 2 to the 2. So we are going to need 2 D flip-flops. All right, so let's give these flip-flops a value. So we're going to have 2 of them. Going to have an input of a clock. Input of a clock. I have this D input coming in, a D input coming out. Okay, just to get everything that we're using different letters, we already used up A, B, C, D. We have X and Z. So let's call this one here R and S. So this is going to produce an R next, an S next, And then this is R input D and S input D. Okay, these RD, SD, that's what we're going to make out as the input of the K-maps. Okay, so before we get too far along, we're going to take our state table and let's make a copy of it. And we're going to make some modifications to this table. The modifications we're going to make to our table, let me just get this to line up on the lines, is now I'm going to put in, and I'm going to put this in red. I'm going to put in R and an S. This is R star, S star. Okay, I got to give a value for A, B, C, and D. The value I'm going to give is, I'm just going to start and I'm going to go 0, 1, 2, and 3. And those are decimal numbers. I got to give those out in binary. So that's 0, 0 for A, 0, 1 for B, 1, 0 for C, and 1, 1 for D. Okay, so that's just the value I'm getting to each of these states. Now, in the next state piece, I'm going to put those down as well. So A is 0, 0. We see we have two A's. B is 0, 1. So I have a few B's. So let me put that down. C is 1, 0. So I'll put that down for the two C's. And then D is 1, 1. Okay, from this setup here, we're going to need to make K-maps. How do I know how many variables I'm going to need to make? Well, you count X, R, and S. So you will need a 3-variable K-map. And we're going to need 2 of these 3-variable K-maps. We are going to need one for R star, which will be our RD input. And then we're going to need one for S star, this SD input. And let's label this as X on one axis and then RS on the other axis. Okay, as I fill in the axis, I'm going to figure out what it is we need to do. Okay, so the first entry is this top row of 0, 0. Where is that top row? That top row is right here. That's A is R is a 0, S is a 0. What we're filling in on the next states, that's going to be the zeros and ones that fill in these two K-maps. Okay. All right, I'm going to use different colors here. So I'm going to use green and orange. So I'm going to highlight when X is equal to 0, I need A to be a 0. So A would be a 0. When X is equal to 1, I need that R to be a 0. Okay, then let's look at this. For S star, X is equal to 0, I need a 0. And X is equal to 1, I need a 1. So that's how we're looking to figure out what it is that we need to write down into these K-maps. Okay, let's do the next one. The next one is 0, 1. Well, where is 0, 1? 0, 1 is B. Okay, so let's do green first. We see that's a 1 and a 0. Then we do orange. Orange shows a 0 and a 1. Okay, we're going to do our next one, 1, 0. Remember, we skip because of the 1 bit being adjacent. So 1, 0 is C here. Let's look at our green spots. That's a 0 and a 1. Let's look at our orange. That's a 0 and a 1. All right, we're on our last entry. Our last entry is this 1, 1. So we look at what needs to be in green. Green is a 1 and a 0. Then we look to see what needs to be orange, which is 0 and a 1. Okay, so let's just clean this up. All right, now we have these two K-maps. We're going to solve it. So let's look at RD. RD is, here we have a pair of 1s. We're on the X0, so that's X bar. And then we look at R and S, only S is staying the same. So that's X bar S. Then we're going to have one term that has nothing next to it. That's an X, an R, and an S bar. And that all gives me what RD needs to be. All right, let's look at SD. SD, we see everything is in one column. So that full column there is X. All the R's and the S changes. Okay, but that's not the end of it. The last thing we need to do is we need to worry about Z, because Z is part of our answer. Now, if we look at Z, there is no X underneath it. So Z, all it needs is two variables, an R and an S. All right, so let's make a two variable K-map with R and S. And in here we see when R and S is 0, 0, our output is 0. So 0, 0 is a 0. Next item, 0, 1 is also a 0. So 0, 1 is a 0, sorry. Next item is 1, 0 is also a 0. And then our last one is going to be a 1. So we're going to solve this. There's no groupings, just a single item by itself, and that's RS. And that would be how we solve the actual circuit for this state machine that we were producing. So in summary, the steps you need to do is from your problem statement, excuse me, from your problem statement, you're going to go to state graphs, from state graphs to state tables, from state tables to the implementation, the K-maps.